Hi, so in Cleansy community management system, they handle some sensitive data like payments and role-based access. During testing, we identified three more security issues: CSP misconfiguration, backend dependence vulnerabilities, and missing Facebook auth integration. Let's take a look at how I fixed those vulnerabilities. Past scan, I found a vulnerability called the CSP failure to define detective with no fallback. This means the site didn't have clear rules on what scripts or styles are allowed, which could let attackers inject malicious code. To fix this, I added explicit CSP directives like script src, style src, and then also base URI form action and form ancestors. I also showed a fallback coverage. So if script srclm is used, a parent script src is also defined. I implemented non-support where a random key is added to entrusted inline scripts and styles, blocking all others. Finally, I set environment-specific config script CSV production for security and relaxed rules in development, so hot reload still works. So this is what I did for CSV vulnerability. I integrated Facebook Auth to allow secure social login. In my EMB file, I added the Facebook client ID and the secret so that we can ensure that these secret keys are not committed into our GitHub repository. In password.js, I configured the Facebook strategy with profile fields and callback URL. In auth controller, I added a Facebook callback function that generates a JWT token. In auth route, I created two routes for Facebook and Facebook callbacks. And finally, in the server.js, I initialized a password. This way, the users can log in with Facebook and keep their accounts linked securely. So when I ran npm audit, I found 13 backend vulnerabilities, out of which there were 5 high and 1 critical, and 4 moderate vulnerabilities. I fixed them using running npm audit fix, and for the breaking ones, I defined the transitive dependencies and removed the outdated packages. After these fixes, npm audit reported 0 vulnerabilities.
My name is Disanagidi MTV. My student number is IT22003546. In this demo, I'll walk you through the security fixes I implemented in our Cleansy application, including XSS protections and secure Google logging with Firebase. For the Firebase configuration, this would be the file, and this would be the front end for the Google authentication provider, and this would be the backend file for Google authentication. And if I demonstrate the Google sign in, we can easily click the button with continue with Google, and instantly the account is created and sign in for the application. And I have done the front-end validation for DOM XSS and backend validation for reflected XSS. Also, there's a small vulnerability which is image source XSS, which is inputting a different kind of a malicious image to the to our application. So I have handled the image uploading process as well, and saving the safe URL in the Firebase. And in summary, I fix DOM-based XSS, reflected XSS, image source XSS, and implemented secure Google logging with Firebase. These fixes significantly strengthen the security posture of our application.
2608. So for the SSD assignment, I have identified 3 vulnerabilities: course misconfiguration, hidden file disclosure, and the package JSON version updates with the sneak security testing. So first, let's look at the course misconfiguration and how I fixed it. Originally, my backend was using the default course setup which was allowed the all access areas by using a star. This meant that any website or bot could send API requests to my API with security risk under OS A01 broken access control. To fix this, I have updated my Express.js configuration. Now only trusted origins such as my React frontend running on localhost port number 5173 during development and my production frontend, if there is a production frontend, are allowed. So in the Beat React side, I have added the proxy in beatconfig.js. This makes the development server smoother because API calls from the frontend get forward to the backend without triggering cause errors. With this fix, only my own frontend can communicate with the backend securely. So as the second one, I have done the hidden file disclosure. So that falls under the OS A05. For that, I have implemented the git ignore file. This is it. So like uh, these files, like the .env and .ds or backups, if accidentally we got it to committed to the git repos, attackers could see that credentials or the secrets and attack to those resources. So I have ensured .git ignore files which exclude these files, and I have removed any hidden or backup files from the deployment. So this prevents attackers from downloading sensitive files or discovering any project secrets. So as my third part, I have used sync and identified 14 vulnerabilities on the package.json file, which has occurred because of the outdated packages. And I have created a PR by using it to update those packages into the latest versions. Thank you.